Welcome to my YouTube channel, A Binary of Civil. Today I am going to explain the first assignment of Geotechnical Engineering-II. Let's start. First question, fine-grained soils when loaded would exhibit consolidation. So, whether the statement is correct or wrong. So, actually the statement is correct one. So, that is fine-grained soils have more void ratio. Fine-grained soils have more void ratio. They are more compressible. When they are more compressible, they will exhibit consolidation. Many people will feel like void ratio is more for coarse grained soil. Coarse grained soil, bada voids है ना, वो ऐसा feel होता आपका. But void ratio is E is equal to volume of voids divided by volume of solids. So for the given solids, how many voids are there? So that is, for given volume of soil, how many voids are there, how many solids are there. So finally, the conclusion is fine grained soils will have more void ratio. Coarse grained soils will have less void ratio. So that is the reason why fine grained soils will exhibit consolidation. Okay, next question. Again, this is a type of multiple answer questions. Multiple, if they will give options like this much. So the question is related to multiple answers. So which of the following is not a root cause of deformation of coarse grained soils? Generally, crushing and bending is not the root cause, and interlocking and rolling are the root cause for deformation of coarse grained soils. So it is a direct question. Next question, the formation of a curved slip surface in a backfill. So for example, if you take a backfill retaining wall here, there is a lot of soil here. So it will be curved slip surface. So curved slip surface is because of sliding of the soil. This is a sliding of soil. So for question number 3 is D is answer. Next question. For a soil sample in odometer. So odometer, the soil sample, if it is a diameter D and H is height, and this H will be D by 3. Why? Because 90% of pressure isobars are within the sample. So that is generally for all the samples of different dimensions, all 100% isobars. Isobar is nothing, points having equal pressure, joining the line of points having equal pressure. So that is nothing but it is isobar. Generally for any soil samples, all 100% isobars will not present in the sample. So depending upon how much percentage of the isobars are present in the sample, the dimensions of the sample can be selected. So here height of the sample is 1/3 of the diameter. Why? Because only 90% of the isobars are present within the sample. Okay, so answer for question number 4 is A. And it is a direct relation. So he has given sigma x and sigma y values. You need to calculate normal stress on any inclined plane which is making an angle alpha. So sigma is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 alpha. In place of y, he has given z, that is sigma z, and tau on that plane at any inclination will be is equal to sigma x minus sigma z by 2 sin 2 alpha. So this is a direct formula question. So question number for 5 question number A will be the answer. And obviously pole is a point on the Mohr circle. Yes, it is a point on the Mohr circle, but it will represent only one plane. All points in Mohr circle will represent one plane. So one point will give you sigma and tau values on Mohr circle. So it will represent one plane. Okay, only pole will never represent all the planes. Okay, so the statement is false. Question number 6, it is a false statement. And For plane strain condition, so we'll write stress matrix and strain matrix for plane strain condition. For plane strain condition, stress matrix is sigma xx, sigma yy, tau xy, tau yx, and remaining all 0. And it is a stress matrix. And strain matrix epsilon xx, epsilon yy, pi xy by 2, pi yx by 2. So remaining all are zeros. So in this sigma zz will be there. So it is related to strains out of plane. Or out of plane means perpendicular to plane will be ignored. So in plane strain condition, strains perpendicular to plane are ignored. Okay, so that is these values can be neglected. These are all related to Z. Okay, next question. If a failure plane, for example, makes an angle beta, then what is at center, what is the angle made by the same failure plane in the Mohr circle? For example, if an element, this is a failure plane, makes an angle beta, then in the Mohr circle, the same failure plane makes an angle 2 beta. Okay, obviously in a physical element, if any angle is beta, then it will become 2 beta. So in the Mohr circle, all the angles are twice the angles which are related in the elemental system. So the answer is B for question number 8. And obviously tectonic motion will occur only when sigma x greater than y. So generally tectonic forces are always horizontal. So that is when horizontal stress is more than the vertical stress, tectonic motion will take place. Okay, that tectonic motion will forms anticlines. Next, final question for this assignment. So you coming to, so which of the following statement is incorrect? Okay, so incorrect statements we need to mention here. So here about granular soil, and this is about cohesive soil. In granular soil, failure is due to rolling of the grains. And in cohesive soil, failure is due to sliding. Okay, it is not due to rolling. So this is most important. So rolling is the cause for the failure in cohesionless soil, that is in the granular soils like sand, and sliding is the reason to cause failure in cohesive soil, that is something like in black cotton soils. Okay, and obviously the center of Mohr circle is sigma 1 plus sigma 2 by 2, but he has given it is a radius. This is a wrong statement. And coming to third statement, straight line passing through pole intersect the Mohr circle at principal. Yeah, these three are correct statements. Okay, so for question number 10, D is the answer. Okay, but actually radius of Mohr circle R is equal to sigma 1 minus sigma 2 by 2. For example, if I draw a Mohr circle, if it is Mohr circle, this is sigma 1 and this is sigma 2. The difference, half of the difference between this sigma 1 and sigma 2 will give you radius of Mohr circle, but he has given summation of half of summation of principal stresses is radius. That is actually not the radius, it is a centroid of Mohr circle. Okay, this is the explanation for assignment number 1 of Geotechnical Engineering 2. I think some of you guys has posted solutions for Geotechnical Engineering 2 assignment. So these are all the answers. Okay, thank you.